the eyes of man, an old idea is about to change. Our concept of time, it will be rewritten. Our words life and death and age all redefined. Toward immortality, man's slow and ancient walk on this planet will become a race. The gain measured in decades, no longer months or single years. The vision, the chance, simply this: that child about to be born will live more years, gather more wisdom, come to know more generations living with the same last name than any human child born in all of history. And it's a journey we've already begun. Today, in government labs, in private labs across the country, scientists are examining the secrets of aging hidden in the chemistry of man. Under their microscopes, the blood cells and antibodies of the immune system, the body's genetic code, the double helix of DNA, the powerful enzymes and hormones that give cells life and then take it away, even the chemical transmitters inside our brain. It is here, life magnified 1,000 times, where the researchers work, and they are nearer to solving the puzzle of life and death than ever before. Dr. Robert Butler, founding director of the National Institute on Aging.
These fields are spectacular. There's just no doubt that they're going to continue to take off. They're already taking off. And by the turn of the century, it's just inevitable that we're going to have many means of intervening in the aging process itself.
If the words "toward immortality" sound like science fiction, consider how far we've already come. Today, in this nation, death from infectious or parasitic disease is rare or non-existent. Smallpox, scarlet fever, cholera, dysentery, diphtheria, tuberculosis, the great killers of our recent past, are now gone, or very nearly so, and the result is a life expectancy today that would have seemed godlike to ancient man. 2,000 years ago in ancient Rome, half the population was dead by the age of 22. Imagine a life expectancy of just 22 years. And then in the middle of the last century, it jumped to 40 years, and then to about 47 years at the beginning of this century. And today, on average, we will live nearly 75 years. Our life expectancy has almost doubled in just 5 generations. It's increased 50% since the year our grandparents were born. But there's a problem here. The way we've extended our lives in the past won't work, cannot work in the future. Let me explain what I mean. In the past, each time we've conquered a disease, we've added more years to our lives. But today, even if we were to find a cure for the major diseases left, our life expectancy would only increase a few more years. Let me give you a couple of examples. According to the Public Health Service, if every variety of cancer suddenly disappeared, life expectancy would increase just 2 years and 4 months. If tomorrow morning all heart disease was suddenly cured, we would live less than 6 more years. So if most of us are to live to be 100, 120, even 150 years of age, it won't be by treating specific diseases, but by altering the aging process itself. And that brings us here to a story about 2 animals, a brown mouse in the pathology lab at UCLA, a white rat at the University of Texas Health Science Center in San Antonio, and about the 2 men who study them, Dr. Roy Walford in California, Dr. Edward Masoro in Texas, both well-known, respected pathologists, both learning about longevity and the extraordinary lifespan of their laboratory animals. Let's begin with Dr. Walford. Each week he swims 2 miles and then runs another 10. You probably wouldn't guess he was 60 years old. What's more, Dr. Walford says at that age his life is only about half over. 120 years, he says, is his life expectancy, maybe more. A belief that comes from the fact that this little brown mouse is still alive. NR-1-243 is her name. Born November 5th, 1978, she's the oldest mouse in the world, very likely the longest living mouse of all time. For the past 4 years, she was fed half the calories her 57 brothers and sisters received, all of whom are now dead. The last one died 11 months ago. Since '68, Dr. Walford has been studying the effects of undernutrition on laboratory animals, proving over and over again
that if you keep mammals such as rats or mice or other lower animals on a diet characterized by kind of the catchphrase undernutrition without malnutrition, and you do that from time of weaning, that you can greatly extend maximum lifespan.
Undernutrition, not malnutrition. The difference is important.
This means that you cut down the total amount of calories in the diet, but you increase the food value per gram of diet. So they're not restricted in essential nutriments. They still get all the proteins, vitamins, minerals, amino acids, essential fatty acids that they should be getting, but it's lower in calories, and they live much longer.
At the University of Texas, an 8-year research project, Underfeeding White Rats, has just ended, and the findings are virtually the same.
They live about 50% longer.
In human terms?
In human terms, would mean if the maximum length of life of a human is 100 years, these animals would be living to 150 years.
But perhaps even more important than the long life of these animals is their extraordinary good health, even in old age.
We also find that those diseases which are associated with age, in the rat, this being kidney disease and heart disease and cancers and tumors, that their time of occurrence is delayed. So the animals are much older before they show the disease, or in some cases, such as kidney disease and heart disease, they don't show it at all.
The next question, of course, is what has all this got to do with us? If lab animals live much longer, healthier lives when they're fed about half the food normal rats are given, would fewer calories in our diet each day have the same effect on us? The answers are both yes and no, depending on whom you ask.
We don't know if these dietary regimens that we used in rats and have been used by others in mice would work in humans. We haven't got a shred of evidence. No one has ever done this kind of study in an animal more complicated than a rat.
Dr. Walford disagrees. He says the restricted diet will work on human beings right now.
If you took 100 humans and put them on, at the age of 18 to 20, on this kind of a diet, and they stayed on it the rest of their lives, then some of them would live to be 135 to 140. Of course, not all of them. Their average lifespan would probably be 100, 110.
110 years would be life expectancy. In other words, the average length of life. But again, some people would live to be 140 years old. Of course, even if Walford is right, there's some caution required here. Cutting your normal diet in half without getting sick and malnourished isn't easy. It almost takes a computer to keep track of the calories and an encyclopedic knowledge of food to make sure you got just the right nutrients each day. Still, Walford says if we did it, if we slowly reduced our diet to less than 2,000 calories a day, Americans would dramatically extend their lives, and that's not all.
No, they'd be much healthier. Those living that long would be more active, more intellectually active, have a greater sense of physical well-being. They'd be sexually capable and to a much more advanced age than normally fed people, and essentially in every way would be healthier. They wouldn't be eating angel food cake every day.
He's doing it. For the last 2.5 years, Dr. Walford has been on a restricted diet, steadily losing weight. 5 days a week, he eats about 1,500 calories a day. 2 days a week, he eats nothing at all. The result? With a little luck, he says, he will live to be 120 years old, which, according to today's records, would make him the oldest man in human history. But let's back up for a minute, because in a way we've skipped over the most important question of all. Not how much did these animals eat or how long they lived, but why? What happened inside their bodies that allowed them to live so long? Can we make those same changes and extend our own lives? As we try to find those answers, we come closer to the most fundamental question of all. Why do we age, and what can we do about it? Man, like every animal alive, has a chemical defense system on duty 24 hours a day, without which, in a matter of hours, all of us would die. This defense is armed with enzymes, hormones, antibodies of 1,000 different kinds that protect us from the natural hazards of life, viruses, bacteria, cancer, even poisons called free radicals produced by our own bodies. The problem, in theory at least, is that this system is just like the rest of us. It grows old, weak, less effective with age, and in the war against disease that begins the day we're born, toward the end of life, the attacking cancer or viruses finally win, the chemical defenders lose, we grow old, and then we die. Now, one way to solve this problem is to find a way to kill each disease one by one, which is what science has been doing for centuries, but there might be another way. We might strengthen the body's own defense and let it kill the disease, whatever it is. In other words, if the most powerful medicine ever designed, the body's own protective chemistry, works so well when we're young, why not just beef it up, somehow reinforce that chemistry when we need it most, in old age? That way we might not only cure diseases that come with age, but prevent aging altogether, or at least slow it down. And it is at this frontier that medical science has finally arrived.
I feel myself that we'll be extending lifespan by simple means easily before the end of the century. Some areas are increasing the DNA repair rate. There's good evidence that that would extend lifespan. Better information about how to counteract free radicals in the body. Other ways of handling the deterioration of the immune system. So there are a lot of things coming off the scientific workbench now, and if any of them work, then we'll have a big step forward.
He doesn't have much longer to live. At worst, a few hours. At most, a few months, perhaps. In fact, according to his doctor, 59-year-old William Keith, retired postman, shouldn't be alive right now. After years of high blood pressure, heavy drinking, and smoking 2 packs a day, only 10% of his heart muscle is still pumping, is still alive. And while this may seem harsh, he is in this condition because, like many of us, in a way, he chose to be. Despite hypertension and a heart attack 12 years ago, he continued to drink and smoke, and sometimes he forgot his blood pressure medications, so now he can't walk, he can hardly talk, and he can't be sure he'll ever see his wife again after today. The point is, extending human lifespan will come in part because science will find new ways to treat disease, and then we'll find a way to alter aging itself. Beyond that, however, how long we live is and will be largely up to us. And some of the hazards are pretty obvious. Excessive drinking, cigarette smoking, obesity, too much sugar, salt, fat in our food, not enough exercise. But there are other things that aren't obvious at all. Wayne County, Georgia, 45 miles southwest of Savannah, hot, flat farming country, and Julian Griffiths has been making a living from this land for most of his life. 63 years old, he bought this farm almost a half-century ago. On it, he's raised wheat, corn, oats, soybeans, hogs, and cows. Because of it, he's cared for a wife and raised 2 children, a boy who became a farmer, a daughter who married a farmer. And it is this land that may kill Julian Griffiths before his time. He lives in a region of the country that was recently studied by a committee of the National Academy of Sciences. They compared death rates in the southeast with those in the upper Midwest.
And it turns out that in this region here, the area where people don't live so long, approximately twice as many of this group died each year as was the case here. So the mortality rate was really almost twice, a really striking difference.
Or said another way, 68-year-old Phil Hamilton of Hennepin County, Minnesota, has twice the chance of living for another year as his counterpart in Wayne County, Georgia. But what is it about this land, this 100,000 square miles from Wisconsin to Colorado, that seems to give life? And what is it about that same number of miles from Virginia to Alabama that twice as often seems to take life away? That was the puzzle before the National Academy of Sciences, and the answer came from the land itself.
Many more minerals, including both trace elements and other elements are present in the soil and the water up in the upper Midwest than are present in the South Atlantic group of states. And these are elements that are essential for health, and some of them are absolutely essential for life.
In the water especially, there is as much as 6 times the amount of iron, zinc, copper, chromium, calcium, selenium, magnesium in the upper Midwest as there is in the river and well water of the Southeast. In other words, the people of the Southeast region have soft water. The water in the Midwest area is hard, and that difference is crucial.
People who live in hard water areas are less likely to die of cardiovascular disease than people who live in soft water areas. And when we talk about water, we're talking about water wherever you find it. The fact that milk is mostly water, and coffee is mostly water, and so is beer and Coca-Cola, and a lot of the vegetables that you eat are. Watermelon is perhaps 90% water. So there's some people who say, but I don't drink water. Well, they do, in the sense that it's a part of almost everything we consume.
Water, then, as it runs over the land and filters through the soil, is a source of food. And from that same kitchen faucet, some of us will be nourished, others malnourished, depending on the soil, the geography of where we live. All of which means there is more in that glass of water than most of us ever imagined.
And these are essential. If you don't have these things, you're not going to do well. And some of them, if you don't have enough, you're going to die. In fact, I think that today we're at about the stage in our recognition of the importance of trace elements, essential trace elements, as we were in the recognition of the importance of vitamins 50 or 60 years ago.
Water, as a source of minerals and trace elements, we don't know enough about that yet. But until we do, Dr. Hobbs says it's not a bad idea to call the local water department and ask about the water in your area. If it's short of magnesium, zinc, chromium, whatever, you might consider asking your doctor about a mineral supplement to your diet. That's what Dr. Hobbs does. He and his wife live in Toledo, Ohio, where the water is relatively soft, and they take a magnesium tablet every day. Well, it's time to move on.
Racer set! And we're set for the 14th annual Peachtree Road Race is underway.
The morning of July 4th, 1983, the start of one of the more famous 10-kilometer races in America, the Peachtree Road Race in Atlanta, Georgia. And there is one man here, lost among the 28,000 runners, whose name will be written in the record book today just because he's here. He started running just 4 years ago, and at the age of 75, he's the oldest man in the race. His name is Glenn Calmes. In 1977, he retired from a desk, a job with the government, and went home to his wife and his garden. He was 70 years old. Almost 2 years later, feeling a little sluggish, a little old, he woke up one morning, early enough so no one would see him, and he started running. Not very far or very long, but for the first time since he was a child, he started running, and it's changed his life.
Yeah, I was sluggish beforehand. The muscles and my joints weren't... one thing I can tell you, I had some arthritis before I started running, and the arthritis has all disappeared. So it must be good from that standpoint.
Still, a couple of questions come to mind here. Did he start too late? Is he too old? Will he somehow hurt himself running 6 or 7 miles at the age of 75? Dr. Herb DeVries, former director of the Physiology Research Lab at the University of Southern California.
The prevailing notion had been that there was no way the older individual was going to improve his strength, his muscular endurance, more importantly his oxygen transport that we all find so important nowadays, his cardiac output, by training. Actually, the older individual responds to training very much as does the young.
It was once thought, and it's still thought by many people, that the ability of the heart to function declines dramatically with aging. But it turns out that if you exercise animals and man, you may in fact not get this dramatic decrease, that the decline in heart function with aging may be slowed considerably. and that the quality of your function of your heart will improve. So that instead of having a tremendous loss in function with aging, the loss is very slight.
The fact is, almost any exercise at any age will dramatically improve your health. It's not just for the young. It burns off fat, strengthens the heart and the lungs, improves the body's use of oxygen. It reduces blood pressure, stress, tension at any age. And while exercise may not extend your life, the research isn't decisive there. One thing is clear. You'll feel younger. You'll feel like you lived more years.
I think that exercise is even more important in an older person. I mean, it's almost as if you make yourself younger by exercising. As far like the prime measure of fitness is a maximum oxygen consumption test, and it declines with age. But a person that stays fit, that slope of the decline is less if they stay fit. And so it is. You're actually slowing down the physiological aging process.
But there's something else here, something this man has discovered and most of us haven't. The word old doesn't mean much anymore. The fact is, medical science and longevity are moving faster than we are. As people keep living more and more years, as we learn more about aging and disease, the word old changes meaning, but our definition stays the same.
We really haven't caught up with ourselves. We're still living with attitudes about aging based on facts about aging that existed in the past, not the facts that exist now, and certainly not the facts that are going to exist in the future when we become age 65.
For some of us, of course, the prospect of extending human lifespan is a frightening idea. In fact, some might say, we live too long already. Why add even more years of arthritis, senility, blurred vision, poor hearing, aches and pain, the trials of being old? It seems a pessimistic but a fair question, and yet some scientists argue that at the heart of that question is a misunderstanding.
There's a big misunderstanding. When people think about living long, they think about being old long. And I'm talking about, and modern gerontology is talking about, extending the period of youth and middle age, and being old for about the same relative period that we are today. People are living to be 150, they should be young and middle-aged if they're 130 and old the last 20 years.
But why stop there? If science can envision a lifespan of 150 years, then why not 200, 300, even 400 years? I know it sounds fantastic, but is there a limit? That's a controversial question in science right now, as yet unanswered, but there are two basic views. First, that there is a time barrier, a genetic limit in each living cell that will allow us to live for a certain number of years, and then no longer, regardless of what we do. But there's the other view, that how long we live is determined by how long our body continues to repair itself, that death is not a function of time, but disrepair. As we discussed earlier, if we could beef up, somehow reinforce the body's own protective chemistry that defends us against disease and degeneration so well when we're young, then our lifespan would depend on how long we can keep that defensive system active and alive.
I think we're about at the point where we're going to find out which one of those views is correct, because of the biomedical research going on, the biochemical research going on right now. We're beginning to see those kinds of breakthroughs already occurring. And so if in fact there is no biological genetic limit to the lifespan, we should be able to see tremendous increases in longevity in the very near future.
But when? How near is the very near future? In time for a man or woman 70 years old today, or 60, or 50, or 40? Or will the imagined breakthroughs come for a generation not yet born? There's no way to know. Extending human lifespan is still theory. What science will find, when they find it, how old you can be and still benefit by it are still questions without answers. Nonetheless, there are a couple of things we can say. First, that there are more researchers today trying to find the answers to aging than there ever were before, and the pace of their work will accelerate. And second, while we wait, for you and me, there is some danger here. It lies in our optimism about medicine and science, our excitement about the promise of new discoveries, breakthroughs, and cures. And yet, like most things, long life and good health won't come from a single magic pill yet to be invented. It'll come the usual way, with good luck and hard work, the luck of who our parents and grandparents are, and hard work in things that aren't magical at all. Watching what we eat and drink and how much, not smoking, getting plenty of exercise, even in old age, staying active, involved, remembering the vital connection between love, loneliness, and long life. And in all of this, getting the advice and counsel of your physician, because in the end, I wonder if most of us wouldn't agree. How long we live will never be as important as how well